A huge meteorite enters our atmosphere, causing an explosion of catastrophic proportions. All forms of life on Earth cease to exist. A giant wave of fire wraps around the planet several times until only ash and dust remain of the green landscape.
But then again, there's another option for our planet's future. The sun could swallow it.
Wait. Who is this?
In the course of its evolution, our star will keep expanding.
Am I the only one hearing this voice?
Until it gets so big that it just swallows our planet without even noticing it.
Hey buddy, that's my video.
I don't think so.
Okay, alright, I'll share it with you. But let's not look that far into the future.
Whatever you say, buddy. How about the fact that the Earth will soon have rings?
Like Saturn?
Almost. Saturn's rings are made of dust and ice.
Yeah, I've heard about that. Thousands of years ago, something really mysterious happened in Saturn's orbit. The planet's gravity tore one of its satellites apart.
Yes, Saturn is a gas giant. It's 95 times heavier than Earth, so it has stronger gravity. It attracted a small moon from its orbit to its surface. Then, it was torn apart from the inside by tidal forces, like the ones between Earth and Moon. Many huge fragments stuck in Saturn's orbit. Some scientists say there was a collision of two moons there. They crashed into each other like billiard balls. As a result, both cosmic bodies turned into a pile of debris and blocks of ice.
No matter how they got there, this debris started circling Saturn. They collided with each other, turning into smaller rocks. It was a kind of cosmic blender. Rocks gradually ground into dust, and huge blocks of ice turned into small crystals. On average, the objects are in the same ratio to these rings as a human fingernail to a school bus.
And soon, similar rings will appear around Earth.
But how? I mean, we have the moon, and it's hard to imagine that it could break apart at any moment. Plus, we don't have another moon to recreate the same collision in our orbit.
Space junk. We have a lot of it. We started launching spacecraft into Earth's orbit in about 1957, and it almost always follows the same scenario.
Ah, yes. The rocket consists of several parts, a booster, or even several of them, the second stage of the rocket, and a cargo, which is contained in a capsule at the end of the rocket. The booster accelerates the rocket to almost orbit and then undocks. The second stage fires up the engines and climbs even higher to get the cargo into orbit. Then the second stage undocks as well, and the cargo capsule releases the satellite or space probe into outer space.
Yes, the first and the second stages of the rocket and the cargo capsule were disposable. That means they stayed in Earth's orbit. Over time, our planet attracted them. They entered the atmosphere and burned up because of friction with the air. But many objects keep orbiting our planet for decades. As of 2021, there are about 170 million space debris objects in our orbit. These are parts of spacecraft, like the bolts used to undock rocket stages. There are also old artificial satellites, operating ones, functioning spacecraft, and debris from collisions that had already happened.
Oh, I've heard about that. In 2009, two satellites collided with each other. Both satellites were destroyed. They shattered into about 600 pieces of different sizes.
Yes, and these sharp metal fragments are flying in orbit at about 6 miles per second. So they could make a trip from New York to London in less than 10 minutes.
Yeah, that's about the same speed at which our rockets fly. And that's about 45 times faster than commercial airplanes.
So these fragments have a lot of energy. As they collide with each other, they shatter and become smaller.
Just like the moon debris around Saturn.
Exactly.
But a bunch of metal debris orbiting faster than the speed of sound can damage our spacecraft, right?
Yes. The International Space Station has already turned on its engines to maneuver once to avoid a collision with a cloud of space debris. Sharp metal parts can damage the hull of the space station or even puncture it. Then the ISS, worth about $150 billion, would be destroyed.
So, if we keep throwing debris into orbit, we could really give our planet the rings.
And then they will be visible even during the day. They will reflect sunlight, just like the moon. And if you look out the window, you'll see beautiful stripes interrupted by the shadow that the Earth casts.
It's an amazing view. Do you want to see an even more unusual one? Imagine that our sun has increased in size by 10 times, and that process is happening right now. Our star is a giant boiler burning hydrogen. It's continually heating up, and every billion years, the sun gets 10% brighter and creates more heat. It'll heat the Earth more, and eventually, the oceans and seas of our planet will begin to evaporate. Thick clouds will completely cover the sky, turning Earth into a giant greenhouse. Our home will look like Venus.
Looks like humanity will no longer be able to live on Earth. What will we do then?
Well, we'll load all the humans and animals into spaceships and move to Mars. At that point, the sun will have warmed it up nicely. Water and carbon dioxide deep in the planet's interior will begin to evaporate and create an atmosphere there. This will cause a greenhouse effect and warm up the planet enough for you to wear shorts there.
And then we'll watch the Earth become a lifeless rock with acid clouds like Venus from the surface of Mars.
Yep, but in about 7 billion years, the sun will start to expand even more and become a red giant. In this phase, it'll become 256 times wider than it is now. So it will completely swallow Mercury and Venus, and the edge of the star will lie just in the orbit of Earth.
So our planet will just drown in the hot plasma on the sun's surface?
Maybe. But when a star burns so much fuel, it loses weight, and so the sun's gravitational field will weaken as well. So it won't keep the planets of the solar system as close to itself anymore. Perhaps our planet's orbit will become wider, and then Earth will become the first planet near the sun. Some scientists believe that at this time, Saturn's moon Titan may gain conditions suitable to become a new home for humanity. Then the sun will begin to shed its upper layers. It'll lose mass and gravity dramatically. This will plunge the solar system into chaos.
Some planets will collide with each other. Others may just fly away into the far dark space. It would be a game of cosmic billiards.
Exactly. And the final stage of the sun's life is a white dwarf. Then our star will become the size of Earth. The planets that survive won't get enough heat from the white dwarf, and its light will gradually fade over billions and trillions of years.
Another challenge that awaits Earth in the distant future has a galactic scale.
The collision of the Milky Way and Andromeda.
Bingo! Right now, the Andromeda Galaxy is moving toward us at 60 miles per second. You could make a trip around the globe at that speed in just 6 minutes.
Yeah, you can already see the stars and gas of Andromeda Galaxy in the night sky with an unaided eye at 2.5 million light-years from Earth.
And in 4 billion years from now, the galaxies will begin the process of merging. No one could be 100% sure about what will happen to the Earth. It could be total chaos when the stars and nebulae of both galaxies collide. Then supernova explosions would go off everywhere. Like fireworks.
But this is extremely unlikely to happen. The concentration of stars and space objects in galaxies is very low. The distances between them are gigantic. It's like if you took a handful of sand and scattered it all over the planet.
The most likely scenario is that by the time the two galaxies do collide, there will be no liquid water on the hot surface of Earth. That would mean the end to all terrestrial life. Scientists believe it can happen in about 3.75 billion years. You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b. And astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there. And if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD0346+246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, This planet is 40 light-years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light-years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620 26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So people approach the rings but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between two colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then, people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on, until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of hundred years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there.
With each passing day, we learn more and more about the world around us. But some of the most fundamental questions that have been bothering humankind for centuries remain unanswered. For example, where does the universe end? Or even better, can it be infinite? We know that our universe is around 13.8 billion years old. That's quite a lot, but it may be even older. You see, some parts of the universe can be too far away for the light from those mysterious regions to have reached us. That's why we have the notion of an observable universe, which is the parts of the universe we can actually see. What happens beyond is unclear, and we might never find out the truth. But the question of whether the universe is finite or boundless depends on its geometry. The general theory of relativity allows three possible shapes for the universe: open, closed, or flat. The open one resembles a saddle, the closed one looks like a sphere, and the flat one can be compared to a sheet of paper. After performing complex calculations and observations, astronomers are almost certain that our universe is flat, and this might mean that it is infinite. On the other hand, it could simply mean that the universe's geometry is so complicated we can't perceive it. There are also other studies that suggest that the universe might be closed. Therefore, it's probably finite. Unfortunately, we're unlikely to find out the truth anytime soon. Now, if the universe was finite, could it have an edge? Since its formation all those billions of years ago, the universe has never stopped expanding. So, now, the regions of space at the edge of the observable universe are way farther away from us than when they emitted the first light. It means the edge of the observable universe is around 46 billion light-years away in every direction. Imagine a sphere with a diameter of 92 billion light-years and a volume of 410 nonillions, which is 410,000 billion cubic light-years. Here you go. It's our observable universe. But no one knows whether these ginormous numbers are the real limit of the universe, with nothing beyond. It would actually be very arrogant to claim that. The chances are there's a whole different world beyond the edge of the observable universe. But even if the universe is finite, it might still not have an edge, like our planet. It's obviously finite, but have you ever seen its edge? Unlikely. So everything depends on the geometry of the universe. Okay, if the universe is infinite, it indeed can keep expanding without getting bigger, since you can't get bigger than infinity. When the universe expands, space itself inflates, which creates additional distance between objects. And astronomers are sure that it happens no matter whether the universe is infinite or not. Now the next question is what the universe is made of. Everything we can see around and in space with the help of telescopes and other instruments is known as normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, some time ago, they hadn't found out that, instead of slowing down, the expansion of the universe was accelerating. It means there is some enigmatic force counteracting gravity. It got the name of dark energy. At the moment, we have no idea what dark matter and dark energy are. As for the 4.9% we do understand, About 74% is hydrogen, 24% is helium, and the rest is heavy elements. Another intriguing question is whether the laws of physics are the same everywhere in the universe. Well, there's no convincing reason why it should be the case, but when scientists tried to measure tiny differences in the constants ruling the forces of nature, it turned out that these laws were the same everywhere and at all times. At the same time, some studies have shown that one constant determining how electric charges interact might have been different in the past. But most researchers agree that this finding is controversial and currently unproven.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall, and if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars, so this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light-years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light-years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light-years long. To give you an idea of how large that is, the Milky Way is only 100,000 light-years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light-years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma-ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the Huge Large Quasar Group. It's about 4 billion light-years across. So it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the Huge Large Quasar Group on the scale, it would be 6.1 billion times heavier than our sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light-years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the Sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the Sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces-Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew, this is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. The observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like 2 drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the 2 bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger. But the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you manage to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory. Black holes tearing apart enormous stars, pulsars spinning at incredible speeds and emitting powerful beams of energy. colorful nebulae with fireworks of newborn stars, galaxies of every possible color and size. All of these are found within our universe, but it's not infinite. It has a boundary, a literal wall, and beyond that, there's an absolute nothingness. Right now, we're going to make a journey to that wall. But first things first, our universe is like a humongous nesting doll. If you open it up, there's a smaller one inside. It's a galaxy. Inside that is an even smaller doll. That's our solar system. And the smallest doll of all is the Earth. Each of these dolls has boundaries that we're going to cross. For that, we'll need a spaceship, and a big one. It also has to be able to move 100 times faster than the speed of light. You get on board and start the engines. 62 miles above sea level is our first boundary. That's 10 times higher than passenger planes fly. This point is called the Kármán line. It separates the atmosphere of the Earth from outer space. Now we fly further to the edge of our solar system. We turn on the hyperdrives and fly past Mars, Jupiter, Saturn, Uranus, and Neptune. We've traveled a distance of 100 astronomical units. 1 AU is the distance from Earth to the Sun. And here's the boundary of our solar system, the heliosphere. Here, the speed of the solar wind decreases rapidly. First, it drops from 620,000 miles per hour to the speed of sound. Then, there's a layer called the heliopause. This is where the wind almost vanishes. And then, our ship experiences a bow wave. This is where we feel the force of the interstellar wind, which collides with the boundary of our solar system. When you pass this boundary, you find yourself in the dark of interstellar space. And here, you can find two human-made objects that made this trip for the first time in history. They're Voyager 1 and Voyager 2. Voyager 1 crossed that boundary in 2004. Voyager 2 did it in 2007. These space probes discovered that the heliosphere is not a perfect ball around the sun. Its southern boundary is 10 AUs closer to the star than the northern one. So, we're moving in interstellar space and will soon approach a stone wall around our solar system. 200,000 AUs further, and there it is. This wall of rock is the Oort cloud. In fact, it's a pile of asteroids that surround our world. Scientists speculate that the Oort cloud could be the source of comets and meteorites that fall to Earth, but they're so sparse that we easily fly between them. Now we're in complete darkness. The Milky Way is about 106,000 light-years wide. In a conventional rocket, it would take billions of years to fly across that distance. But you throttle to the max. You masterfully fly past the stars and planets as if on a racetrack. And within minutes, you're at the edge of our galaxy. There's no more interstellar wind. All you see are bright dots somewhere in the distance. These dots are huge galaxies. We need to look at a map to make a route to the edge of our entire universe. You're here, near the Milky Way galaxy. It's part of a cluster of galaxies called the Laniakea supercluster. But even this huge thing is like a little street in a big city. Zooming out, we find Hydra Centaurus supercluster. Thousands of galaxies on the map look like little dots. Maximum zoom out. This is our entire observable universe. We thought it was infinite, but we may have proof that it has a boundary. It's here, 10 billion light-years away from our home. Even if you travel at the speed of light, a trip there would take twice as long as our whole planet has existed. During that time, the sun will either fade away or explode like a supernova, destroying our entire solar system. And if you can live that long and then return home, you will see that our galaxy is there no more. It's long since collided with the Andromeda Galaxy and merged into one big cosmic body. Luckily, your ship is able to warp space-time so that this journey will literally take a few seconds. Boom! Congratulations! You've arrived at your destination, the Eridanus supervoid. Some scientists believe this location is the evidence of collisions of our universe with something big enough to leave such a large scar. The Eridanus supervoid is an empty and cold space 1 billion light-years wide. If you think of this void as a cup, it would fit at least 10,000 galaxies, and it appeared after an accident of gigantic proportions. The object that crashed into our universe was another universe. Yes, other universes may actually exist. Imagine that our entire universe is a huge bubble that contains all the clusters of galaxies in the observable universe. There could be an infinite number of such bubbles. They could have been born during the Big Bang. These universes may be different from ours. They may have other galaxies and nebulae. But these bubbles could also be parallel universes. This means that if you chose cereal over oatmeal in the morning, in another universe, your twin would choose the oatmeal. Every choice you ever made in life had completely different consequences in a parallel universe. And because the number of choices are infinite, there's a whole infinity of parallel universes. So, like a regular bubble, our universe has a wall that is near the Eridanus supervoid. Long ago, another bubble flew past ours. As they approached each other, their gravitational fields began to interact. Our boundary wall began to deform and pull toward the other universe. The same thing happened on the other side. Then the walls of our universes came into contact. But as these bubbles moved, their connection began to break, and the other universe just ripped a huge chunk of ours. A cold void was formed at the point of collision, and that was the Eridanus supervoid. The problem is that the universe looks the same to the observer, regardless of point of view. For example, imagine a basketball hanging in the air. Now, if we put an ant on the ball and tell it to find the edge of the ball, it will start running around it, making an infinite number of circles. But the landscape around the ant will not change. All it will see is a rounded horizon. That's because the ball remains the same from any point of view. The same thing happens to us when we try to find the edge of our universe, all because we imagine the world in three-dimensional space, and our view is limited. For example, you see an ordinary square in two-dimensional space, but if you add depth and change the point of view, voila, it's a cube. If we could see the universe in four-dimensional space, a square might be something completely different. But maybe we can leave our home bubble. The key to traveling to another universe might be inside a black hole. A black hole is one of the most mysterious objects in the universe. They're so heavy, they warp not only space, but time as well. It's like putting a heavy boulder on a net. The net will sag, and the closer you get to the boulder, the stronger the curvature is. Once you're in the gravitational field of a black hole, you can't leave it. We still don't know what might actually be in the heart of a black hole. Some scientists speculate that white holes also exist. Theoretically, they should be born along with black holes. Except for the color, they're the exact opposite of black holes. Nothing can come close to a white hole. At the moment, there's no data on such objects, but general relativity theory suggests they do exist. There's also a theory that a black hole may be a passage to another universe. When you get into a black hole, you can come out the other side through the event horizon of the white hole. So you bypass the boundary of the universes and find yourself in a completely different world. But we may have proof that a white hole exists. In 2006, scientists discovered an unusual burst of energy somewhere 1.6 billion light years away from Earth. This burst was unique. It didn't look like a supernova explosion or even the merger of two black holes. Some astronomers believe it was the birth of a white hole. But because it was unstable, it was destroyed almost immediately. This process was reminiscent of the birth of our entire universe, the Big Bang. So, scientists called it the Little Bang.
Without knowing languages, people from different countries won't be able to communicate with one another efficiently. And imagine if some extraterrestrial civilization sent a message to Earth. How would we figure out their intentions? Like, do they want to get to know us better? Or is it a warning about a full-scale intrusion? It must be terribly hard to bridge the gap between us and creatures whose minds, bodies, and habitats are totally different from ours. So, to practice decoding potential extraterrestrial messages, an artist-led group created a mock message from stars. It was the most alien missive the world had ever seen. Even though it was written for humans by humans, it was as non-human as possible. The message was sent from Mars to Earth, and 3 observatories detected the transmission 16 minutes later. Unfortunately, so far, no one has deciphered the message, but many have been trying to do it. There are only 3 people in the world who know what the message means. One of them is the project's founder, Daniela De Paulus. She and 2 other co-authors created the message after consulting with scientists, poets, programmers, and philosophers from all over the world. The main challenge for them was to get rid of anthropocentricity to make the message as realistically alien as possible. So the team immediately ruled out any kind of language-based communication. Even though now they refuse to confirm or deny that the message contains text, the creators were also considering using mathematics. Yes, the fundamental concepts of this science are universal, but different cultures may represent math differently. DePaulis and her team struggled to compose the message for years, experiencing massive writer's block. But eventually, in 2019, the idea was formed. 3 years later, in 2022, a major breakthrough occurred when the team drew inspiration from a short story called A Sing in Space. And a month before the transmission, an astronomer joined the team, adding a mathematical touch to the message to make it more universal. Since the first announcement, the project has attracted loads of puzzle lovers. They started to exchange ideas, hoping to solve the mystery. Some of them were among the first people to extract the raw message from the ExoMars orbiter's broadcast. It was a 40-gigabyte string of numbers interwoven with the alien message. If it had been real, it would have arrived unannounced, of course. But in this case, the signal came at a precisely scheduled time. Now imagine peeling layers off an onion. That's what filtering the data segment looked like. But after a week's effort, the enthusiasts received an image of 5 speckled clusters against a blank background. After that, the speculation on the meaning of this picture started. Could the message be hinting at the alien's appearance? Was it Morse code? Maybe it hid some genetic secrets? One user even enlisted ChatGPT to help decipher the message. There was also a theory that the image was a star map with the location of the alien civilization. Another suggested that the dots resembling constellations could be molecules. Probably, they were part of the biosignature of the foreign world. But decryption is the process of making sense of some message for which only the intended recipient has a key. That's why this kind of code breaking is much more difficult than decoding, because you need to guess the missing key. Another tricky part is where to start. Every attempt feels like a stab in the dark. You might believe that you have started to see patterns, but you need to stop and think whether it's true or you're just projecting. The community is still trying to decode the message. At the moment, there are more than 30 ideas for how to do it. Only after that can people try to understand its full meaning. How about you? Would you like to try and take part in the process? Maybe you've got some idea? Then share them with us.